An important class of functions are called sinusoidal functions. They are of the form y is equal to a times the sine of bx plus c plus a d, or y is equal to a times the cosine of bx plus c plus a d. Each of these are called sinusoidal curves. You'll be asked to do one of two things with these. Given an equation, produce the graph, given one of these equations where a, b, c, and d are constants, be able to produce the graph, or given the graph of one of these, be able to recognize that it would have an equation of one of these forms and find the a, b, c, and d that would make that work. Doing either of those objectives comes because we understand very thoroughly the graph of the sine and the graph of the cosine. This function is the graph of a sine. Notice that the sine curve when x is 0 is 0. Then it begins to grow until it gets to a height of 1. It comes back down to 0 and continues that process. Now notice from here to here is one cycle. The length of that cycle is called a period. In this case, this is just y is equal to the sine of x, and x is measured in radians. So notice here a little bit more than 6. That number right there, when it gets back to the starting point, that is 2 pi, which is a little bit more than 6. It starts out at 0. At pi, it's here. Remember that pi is 3.14 something. So when we're at pi, we're back at 0. Then it drops down and comes back here. There's one cycle. Okay, this is an odd function. Now let's take a minute and look at the cosine. The cosine has exactly the same shape as the sine, but notice that when x is 0, the cosine is 1, and then it starts its trek. So the cosine is kind of starting where the sine ends up being at 1. Okay? It's good to kind of see that connection between those two. They have exactly the same shape. It's just that the cosine is shifted. Now you need to have that memorized. You need to know that the sine starts at 0, and then it gets through one cycle when it gets at 2 pi, and then it continues on. That the highest that it gets is 1, and the lowest it gets is a -1. The cosine, on the other hand, starts at 1. Again, when it gets around to 2 pi, a little bit more than 6, at 2 pi, it has gone through one cycle, and then it just starts over again. The period on both of these is 2 pi. It's just a matter of where each of them start. So, of course, both of these are special cases of sinusoidal functions. Notice that the a value in this one is 1, b is 1, c is 0, and d is 0. Then this actually is of this first form. The cosine, on the other hand, if we're using this second form, the cosine in this form has the same situation. A is going to be in this equation is going to have an a value of 1, a b value of 1, a c value of 0, and a d value of 0. Now, anytime that we've got this wavy motion, this sinusoidal motion, if we have the graph, we want to be able to produce the equation. If, on the other hand, we have the equation, we know it's going to have this wavy motion, and we want to be able to produce that particular, whether we have the equation, we want to be able to produce the graph. If we have the graph, we want to be able to produce the equation. Now, in this app, we're examining y is equal to a sine bx plus c plus d. And I've got sliders for a, b, c, and d. Notice I've got a set to 1, b set to 1, c is equal to 0, and d is equal to 0. you can see the equation over here, that object equation. All right, now let's begin to adjust some things. Let's adjust A and see what happens instead of having 1 times the sine. In other words, right now we're really looking at the sine of x. We've looked at that before. But now let's start to increase 1A and see what happens. It stretches the graph in the xy direction. Notice that it doesn't change. The graph doesn't change where it's crossing the x-axis. It simply raises the high points and lowers the high points. If A becomes negative, then it switches the graph so that where it used to be high, it's now low, and where it used to be low, it's now high. If we pull that back so that it's right on 1, then we really just have y is equal to the sine of x. Now you can watch this function over here and see how it's changing as we move these things. Now let's examine what happens if we change the b value. That's this value right here. The c and d we're still leaving at 0. If that b value begins to increase, then notice it squishes the graph and makes it vibrate more quickly. It goes up and down faster. If we stretch it back out, bring it to 0, then over here it's just squishing the other way. Okay, so when b is equal to 1 and a is equal to 1, we just have y is equal to sine, but b does some squishing to the right as it gets bigger. Now notice between 1 and 0 it begins to stretch it out. But if we get bigger than 1, if b gets bigger than 1, it squishes it together. So between 0 and 1, it's stretching it out. For anything bigger than 1, it's squishing it together. Okay, let's bring that back to 1. Let's examine what happens to the c value. The c value just literally takes that graph and slides it to the right or the left. Now notice something kind of crazy. It is maybe counterintuitive here, but if I make the c value larger, it moves the graph to the left. If I make the c value smaller, it slides the graph to the right. Okay, bring that back to 0 if I can. Okay, so that's what this c value does, is it tends to shift things right and left. The d value, look at that. As the d value gets bigger, the graph lifts up. As the d value gets smaller, the graph lifts down. Okay, so that's part of what we need to understand here, is what each of these constants in this equation do. The a value makes the graph bigger in the xy direction. The b value makes the graph bigger in the x direction. Okay, stretches it out or shrinks it up in the x direction, and it kind of does that in a counterintuitive way. The c value shifts the graph right or left, and the d value moves the graph up and down. Okay? So, if we see one of these curves, this up, down, wavy curve, we know it's going to have one of these kinds of equations, and we want to be able to find the a, b, c, and d for it. If, on the other hand, we are given one of these equations, we know that it will be one of these wavy forms, and we want to be able to produce the graph for that. Now we'll look at how to do each of those tasks in some of the next videos.